Hello everyone, myself ABHISHEK. I am here along with my teammates Bhuvan KB, Pbl and JS Rohit. Our project title is hand gesture to text conversion, and we have already completed phase 1 and phase 2 of our project. In phase 1 we have introduced our project idea and identify the problem faced by deaf and speech impaired people, and explain the objectives of converting hand gesture to text. And in phase 2 we have explained the working process of our components we use in our project. In phase 3 we are going to present actual working of our project under the guidance of Shilpa ma'am and Pbl coordinator Darshan sir and HOD ma'am Asha K. These are the contents of our project: introduction, progress statement, objectives, software and hardware requirements, system design, result and discussion, and last one conclusion. First one, introduction. Communication is very important in our daily life. However, deaf and speech impaired people find it difficult to communicate with others, and they usually use hand gesture and sign language for communication with others. Most of the people do not understand their gestures, and so our project hand gesture to text conversion is mainly designed to help deaf and speech impaired people. The system converts gestures into text readable format so that others can easily understand their message. Based on problem statement, deaf and speech impaired people face communication problem because their hand gestures are not understood by everyone. Many existing systems are expensive and difficult to understand, so there is a need for a simple and affordable system that can convert gestures into text in real time, making communication useful. And next part of the continuum, Bhuvan.
Thank you, Abhishek. Next, I will be reviewing with the objectives. First one is wearable design. This is wearable design to develop a lightweight globe interfacing integrated with a sensor, that is MPU. So next, real-time classifications to implement an C++ algorithm that maps the raw accelerometer data to specify high priority. So like we have mentioned, messages like food, water, washroom, and emergency. So next, global monitoring to establish Wi-Fi link between the patient's room and the assistant's room, that may be the nurse or doctor. Next, feedback mechanism. So to provide multi-module feedback sensing using, we have described LCD, that is visual text, and some buzzers and LED for audio and visual emergency alert. So affordability. So this is an affordable device you can use with. Next, software and hardware requirements. So hardware requirements, we have used microcontroller ESP32. So the purpose is that central processor and Wi-Fi purpose. So next, sensor, that is MPU6050. It detects the gesture and takes detection. Next, display. So display, we have chosen the 16:2 with I2C, which is a local text output. Alert system, we have integrated 5-volt power buzzer and the latest audio and visual alarms. And next, connectivity 2.4 GHz Wi-Fi, and we have used link cloud communication. Software requirements, Arduino IDE. This is a very integrated development environment used for writing, compiling, and dumping the code into the ESP32. Next, we have used linked IoT platform. So this serves as a IoT cloud-based and dashboard notification and engine. So from ESP32 to mobile devices or laptops. So next, C++ programming. This used to develop a logic and visual and sensor data fusion to different between the four patient gestures. So next, essential libraries we have included in the code. That is Ring, Simple, ESP, 30.h, and wire.h. crystal that is accuracy and ADA for this is sensors library accuracy. Thank you. Next will be continued by Troy.
Thank you, Bhuvan. And the system architecture and diagram. As a main sensor, we use Pbl 6050, which converts physical data into the digital, which goes to the controller, that is ESP32, which process it is a brain of our project, and the respective message will be displayed in the LCD, which is I2C integrated, and we added a 5 volt buzzer and a red LED. For the alert, it will give red LED, and the person is good means not any idiot means it will shows red LED. And to the IoT, we use Blink software, which we can use in our laptops and phone through internet, and we want to connect ESP32 with our Wi-Fi. And the next one, result and design. The implemented smart gloves system was tested in the real-time conditions. We have successfully compiled this in the real world, and we used in our hands, and we tilted that shows a real-time output, which we can see in our video only. We will add that in the next right hand. The gesture recognition and accuracy. We got approximately the correct accurate answers only. When we tilt the right side, it will give I want washroom or the respected things in the 4 direction. We use X and minus X and Y and minus Y axis we use. And the response latency, we add some delays for the all other sudden movements, and it will be remotely controlled by the Blink software. And IoT functionalities, when the person is not with us, they are far from us, we can also communicate them or see that through the Blink software. We want to connect ESP32 with our home Wi-Fi, and we can see in the application the person is want to washroom or food or emergency through that Blink software. And cost and benefits, it costed about 1,783 rupees. It is minimal only. We can use for all the disabled persons which they can't speak. They want to convey their message to the doctors or take carers for them. And continued by Deepak TL.
Myself, Pbl, I am going to explain the result and discussion of our project. The result indicates exam-based gesture recognition system, which is recognition system which approach a very effective and assertive communication. Unlike using cameras and unlike camera-based system, we proposed a solution which is independent of lighting and background, which we can use all the day without any background and camera issues, which is suitable for everyday use. The variable design improves portability and user comfort, while threshold-based logic reduces fast gesture detection. Finally, conclusion: the IoT-based sign-to-speech or sign-to-text conversion system provides cost-effective solution to overcome barriers faced by impaired and bewildered patients by irrigating gesture sensor, microcontroller, and an IoT platform. The system enables the real-time gesture recognition without any delays by using microcontroller and IoT platform. The project demonstrates the practical use of an IoT in healthcare by improving accessibility, enhancing patient independence, and reducing the response time. With the future enhancement to such machine learning-based gesture recognition, voice synthesis, and vital sign monitoring, the system has
strong potential of real-world hospital and home care use